Thank you very much for the introduction and opportunity to be with you today. Let me just get to my presentation. Okay, I don't see if the problem is going to come back again. It is a great pleasure to be here today, and as you can see, I'm going to switch a little bit gears and talk about flooding, but not directly basement flooding, and bring into the consideration some of the issues that have been raised this morning as questions, and specifically talk about the climate change. As a background, this talk is part of the much larger project that's been done with the support of the City of London and for the City of London under the title Assessment of the Infrastructure Vulnerability to Climate Change. And the results of the project have been presented to the city. My understanding is that the City Council will be discussing recommendations of the project somewhere in June of this year. The project done before this one was the reassessment of the IDF curves for the City of London, taking into consideration the climate change impacts, and the results of this assessment are also going to be presented to the Council next month. Work done on this project is the product of the number of people, and you can see I am very thankful for their help. This is an interdisciplinary team, 2 universities, University of Western Ontario, University of Waterloo, and the number of people involved in the project are listed. I like to start my presentations with conclusions, so for those of you who would like to stretch, maybe this is it. My key messages are that the urban environments and the infrastructure are vulnerable to climate change, and the fact is that adaptation cost can be very high. I am going to try and convey through the presentation one idea, that adaptation to climate change can be seen as risk management. And the overall objective of this study was to develop a methodology for assessing the risk of climate change to infrastructure, and that kind of fits into this key message, that we look at adaptation as a risk management process. In order to do that, there is a very clear need for comprehensive risk assessment methodology that should kind of collect all the information and evaluate the information, examine the information, in order to increase our understanding of the relevant climate effects and their interactions with the different types of municipal infrastructure. The cost is rising by day. The cost to adaptation. And my final message is that the time to act is really now. Every day of delay is just going to increase the cost of adaptation. The presentation is organized to kind of walk you through the project and present some of the results through of that case study. So I divided the presentation into 2 sections where I will be talking about the methodology. The first part, including climate modeling, hydrologic modeling, and hydraulic modeling, will be focusing on the assessments of the hazards and how can we bring the climate change into that process. And then the second and more important is a presentation of the original methodology for assessing the risk to the infrastructure. And I'm going only to talk about the buildings in this particular presentation, in spite of the fact that the project involved various types of infrastructure and the risk assessment. At the end, I'll present some of the results of the case study application for the City of London in Ontario and conclude my presentation. So this is the kind of outline of the work being done. As you can see, there were two distinct parts of the overall process. The first one focusing on the hazards, and following a little bit more traditional procedures that involve bringing the climate change impacts from the global scale to local scale, finding out how to convey and forward and find out how these local climate impacts are going to affect the infrastructure. And then we needed really a different way, or the new way of assessing the risk of the infrastructure. And that's what I consider to be one of the major, actually there are two important contributions. One contribution was how we brought the climate into the hazard analysis, and the second one, how we developed this risk assessment and how this risk assessment has been done. Let me walk you through the steps of the hazard analysis. The first idea, and this is already the innovative kind of view of bringing the climate change impacts down to the local scale, was instead of selecting a particular climate model, we decided to look at the broader range of possible impacts that climate change can bring to the municipalities, in this particular case to the municipality or the City of London. So instead of selecting one particular global climate models and finding ways how to downscale this information to the local scale, we looked at a broad range of various climate models, their potential impacts for this particular locality, and then identified two of them as a kind of two scenarios that are determining the potential range of impacts. By doing this, we actually try to respond to the uncertainties that are involved with selection of the global climate model, as well as the selection of the various scenarios that these models require for their outcome. So we named them as the lower bound and the upper bound climate scenario, and both of them were then combined with the local information of local observation, historical data, and the tool that downscales this global data to a local scale. These particular tools are known as weather generators, and we use one. I'll tell you a little bit about the tool that can effectively do that following some kind of non-preventive type of analysis. So the reason for selecting two scenarios is kind of presented here. This is only the presentation of one of the variables that the climate models, global climate models, provide, and you cannot see the text. This is okay. These are the various models and the various scenarios, indicating that choice of the model and the scenario may actually result in a different value of the particular variable, being temperature, minimum, maximum, precipitation, mean precipitation, or whatever variable you're looking from the global climate model. So that motivated us to kind of look at the boundary conditions, and as you can see with these red bars, I indicated the choice of the two models that have been selected and used in the analysis for the City of London. This information from the global models was downloaded for the location of the watershed. You're talking about Upper Thames River watershed within which the City of London is located. City of London is under here. This watershed is about 3,500 square kilometers, and there are observations within and around the watershed that were useful to be combined with the global climate data that was provided only with one point in the region, and then processed through the weather generator to give us a long sequence of potential climates that may occur over the watershed. What you see on the right-hand side is simply the animation of the results of this simulation. These are the potential precipitation patterns that may occur over the watershed over the long period of time. That was done for both scenarios, the lower and upper bound scenario, in order to determine kind of a range of potential impacts of climate change. This was the main input. This is the kind of climate analysis being done, and that provided the main input into much more traditional analysis in converting now this meteorological data into first hydrologic information, and then later on through the hydraulic analysis into inundation depth and extent and so on. So the second step, we processed the information through the hydrologic model. In this particular process was very much traditional. We utilized the model that's already being used by the Upper Thames Conservation Authority. The only thing we have done, we kind of improved the resolution for the territory of the city. The reason being that the model in the current form covers the whole watershed, and therefore only 32 sub-basins are not sufficient for the detailed analysis that's required within the city. So we nested another level of the hydrologic model with a much coarser, much more detailed resolution within the territory of the city, and used the existing model as a boundary conditions for the analysis within the city. So this is the final form of the hydrologic model, and this hydrologic model allowed us now to transform the information from the climate to climate scenarios into kind of hydrologic variables. In this particular case, the runoff, and the runoff was estimated through the modeling exercise and the 169 locations that were required for the detailed hydraulic analysis within the city. The data from the outputs of the hydrologic model were processed using traditional statistical analysis. What you see here are the kind of probability of the flows at particular location for the two scenarios. And now the question was, how are we going to use this information in order to proceed with the further with the hydraulic analysis and the assessment of the impacts. So through the communication and work with the engineers in the City of London, we opted, with the involvement of the people from the Upper Thames Conservation Authority, we opted for 2 regulatory floods. And using basically the statistical information obtained after the hydrologic modeling, we found corresponding 100 and 250 year floods. And now we had 2 climate scenarios, upper and lower bound, and 2 hydrologic scenarios, 100 and 250 year, to proceed with. This information, as I said, was generated at 169 points around the city, and then the very traditional hydraulic analysis was used to convert the runoff or the flows into potential impacts, basically the inundation. The type of model being used is the Hydrologic Engineering Center River Analysis System that was used together with the GIS pre-processing and post-processing tool. And that particular analysis gave us something like this. Basically, the extent of the inundation that corresponds to the 4 scenarios, 2 climate and 2 hydrologic scenarios. And the shade of blue was basically the depth of inundation at different locations. So this was the outcome of the hazard analysis. So these maps were generated for the whole territory of the city and for 4 different scenarios. We were able to analyze different locations. We were able to kind of compare, for example, the extent of the inundation corresponding to one climate scenario with another. We were able to compare, for example, the extent of the inundation compared to existing conditions, which are called kind of historic conditions, in order to see what are the variations that the climate change will bring at the different locations. That was the main input into the risk assessment, and the risk assessment methodology was detailed, was developed to kind of basically introduce the non-traditional way of looking the risk of flooding as the product of the probability of hazard and the consequences. And the consequences were kind of combining the economic information of the monetary value, and as I'm going to talk a little bit more about various kind of aspects of the potential consequences for flooding. So the process took the basically inundation maps for all these 4 scenarios, and that the probability values associated with these different scenarios where the measures of the hazard or the probability of the particular event. The data that was combined with this information, with the hazard information, in this particular case, I'm focusing only on buildings, was provided by the City of London. We included commercial, industrial, institutional, residential buildings. And the area that was covered by the inundation extent for this war scenario included more than 120,000 buildings. We also integrated in the risk assessment process the traditional economic information, stage damage curves. They're provided by the Ministry of Natural Resources, and also some curves were developed for the types of infrastructure that they were not available. And finally, the detailed economic data about each property within the city was provided from the Municipal Property Assessment Corporation that basically handles and manages all the economic data for the City of London. So using this detailed information, we were able to assess the risk and quantify also the risk impact, indicate what is the contribution of the climate change, and compare the potential impacts, taking into consideration this range of two scenarios that I described at the beginning. Since the main purpose of doing this risk assessment was to kind of assist City Council with making decisions, prioritizing, and understanding better risk, we decided to very carefully plan how are we going to present the information, calculated risk for each of these 120,000 pieces of infrastructure will be very hard to convey to City Council if you would like to develop the broader understanding, what is the level of risk, where is this risk kind of occurring within the territory of the city, and how should we prioritize that. So we decided to present this in a particular form using the spatial kind of division of the city territory, and we selected dissemination areas, the way how the city is basically the area divided. And this particular form is, I think, originates from the Canada Post and identifies the areas with the equal number or very close number of the population density. So as you can see, you may have a very large dissemination units somewhere outside where the density is not very high compared to very small units that are indicating higher density of population. So dissemination areas were now represented the main spatial unit within which each infrastructure or all the elements of infrastructure are analyzed. And for each of the dissemination areas, the total risk was assessed or calculated so that we can represent then the risk in the kind of graphical form on the maps that are going to be easier, I think, to communicate the message of risk. When you look at the buildings, and I'm including here also critical facilities, there are different ways and kind of mechanisms that they will fail to flooding. And mostly the damage may occur to the structure, in some cases the content, and also the aspects of evacuating people is associated with the location of the building and the potential impact that flood may have on the particular building. For the critical facilities, including police stations, fire stations, hospitals, schools, and so on, we looked a little bit more. We looked also beside the structure, equipment, and contents. We also looked at the service and what these particular facilities may not be able to provide in the case if they are flooded. Okay, so the first step was assessing the probability of hazard, and that was relatively easy, just presenting in the kind of spatial form our inundation. So what you see here are these 4 different scenarios. These are just the kind of schematic representations of the inundation areas for the climate change lower bound 100-year return period scenario, climate change upper bound 100, and 250 lower and upper bound. So these were the 4 main inputs provided by the hazard analysis. And obviously, depending on the 100 or 250 years, they were carrying the different probability. The second step was to look at the consequences from flooding. And this is where we did something, I think we innovated a little bit the procedure. The consequences were calculated using the 3 different multipliers: loss of function, equipment, and loss of structure, in order to reflect, the role that different infrastructure buildings are serving, and in order to kind of capture all possible failure modes that these different structures may experience. What was interesting that some of these we were able to assess relatively easily. Loss of function or equipment was on the kind of binary mode, occurring or not occurring, being 0 or 1. However, some other aspects may require very detailed economic information, inundation information, and possibly even the subjective information on the perception of the risk that may come from those who are using these different infrastructure components. The procedure was relatively, simple presentation of the procedure is here. So the floodplains, or the maps that were indicating the extent and the depth of inundation, were integrated with the aerial photography and the detailed information provided about all the buildings, and then combined with the stage damage information or the economic data provided for that, so that the whole process then ended up with the calculated risk for each piece of infrastructure that was clearly located at a particular location within the city. This is just a kind of indication how this was done. You can see, for example, a small section. This is the downtown area where the North Thames joins the South Thames and continues as Thames. The shade of blue indicates the depth of inundation. You can see the scale, and the location of each building was very clearly kind of identified. With the geographic information systems and the data provided as GIS layers, we were able to kind of now compare the depth to the basically location of the building and identify the inundation of each building, how deep water was at the particular location, and then using the damage stage damage curves, find out the corresponding damage. So for the selected or identified depths, we were able to find out the damage, and that was the key piece of information in proceeding with the calculation of risk. And that was a deterministic, or what I say would be really quantitative type of analysis. This is relatively traditional, except that we looked at these 3 different aspects of potential damage. What I think was new is we tried to combine now this information, especially when we are talking about loss of structure, with some subjective type of information that the stage damage curve does not make a major difference between the 1-story building built 2 years ago versus 1-story building built 100 years ago. The same stage damage curve is provided by the ministry that corresponds to 1-story type of building. So what we try to do is now, from the direct knowledge and interviews with the people, as well as the people in the city, to take the subjective information, how much this will be modified, how much the damage will be modified based on the, let's say, age of the building, type of the material being used, particular maintenance if you're talking about some municipal buildings and so on. And that was done through the introduction of the totally new kind of theoretical concepts of the fuzzy sets, where you can relatively easily transfer this subjective information into some kind of quantitative type of analysis, where the current state or the acceptable state is defined with one of the so-called membership functions, and the critical state with another, and the overlapping area identifies a kind of level of that subjective risk that will be going then and combined with the quantitative data generate the overall risk to different infrastructure elements. At the end, we use the kind of monetary values. They were basically dollar values associated with different particular building types or infrastructure elements, and that were all combined into a relatively simple but complex relationship that brings now the probability of hazard, the different type of impact, and the monetary value together, and calculates that value for each element of it, for each building, for each element of the infrastructure. The calculation is then being kind of transferred, or the information is being transferred into maps by integrating or by simply adding the risk value within each of the dissemination units by identifying simply how many of the buildings and which are within particular dissemination unit. Let me show you some of the results for the City of London. That was the methodology. We applied this methodology from the beginning, hazard analysis to the risk assessment to the City of London. We didn't look only buildings. I'm going to show you some of the results only for the buildings. We looked 9 types of infrastructure, much larger number of infrastructure pieces and elements, and we assessed the total risk because that was the objective of the study. The tables and maps were produced for these 4 different climate scenarios, 2 lower and upper bound and 100 and 250 year return period. And we were requested also to utilize the information that was representing the kind of historical or the current level of damage. I have a reservation of kind of comparing these because we are talking about apples and oranges. The way how, for example, maps are developed here and inundation is very, very different, done a very long time ago, and does not correspond to kind of methodology that we have done and implemented in this process. But it is an important piece of information so that you can somehow compare the current state with the potential impact that the climate change can impose on the city. The maps were used to identify the areas of high risk. And this is just giving you, for example, the extent of the inundation for different climate scenarios, the number of buildings within a number of critical facilities. So that's all what was done in order to generate this final information. And as I explained, then from the tables for each element of the infrastructure, we went into dissemination units or dissemination areas. We added all the information to come up with a level of risk that will correspond to this particular spatial location, for this particular dissemination area. So at the end, we were able to produce a map like this, where the shades of red are indicating the extent of the risk, that kind of total risk. And this map is created basically by plotting the information for each dissemination area. Here are some of the results and why these maps are useful. This is the counted year lower bound scenario, and you can see, actually you cannot see much. The resolution is not extremely good. But for some of you from London, you may recognize particular areas. It was very clear that these darker red areas are the areas of high risk. And these are the areas that we kind of identify. One is on the Potterfield Creek, where there is a particular culvert under the railway that creates the backup effect. And we found that for the larger flooding that may be the consequence of climate change, a considerable area will be flooded as a consequence of insufficient capacity of this culvert. The second location was the location of the Brookdale Dyke, which does not have sufficient height to respond to the impact of the climate change, and the area behind the dike will be affected in this case by the lower bound climate scenario to this level. The third area identified was the area of Coves, which is a very known area, mostly trailer park basically, where lots of people may be affected, lower income type of area, and very, very vulnerable socially. Similar maps where we were now able to generate the maps for all the scenarios, upper bound, 100 year, 250 lower bound, 250 upper bound. And having all these maps, now we were able actually to do the various analysis, the kind of comparisons. We were able to, for example, compare the historic information with the climate change information. And that was done by comparing these two 250 year maps. So we were able to say, for example, what is the contribution of the climate change to potential increasing risk of flooding. I can tell you that the total number is for the whole territory of the city about 78%. Then we were able to analyze, the do different comparisons in order to answer some different questions that the city councillors may have. One was, for example, the analysis of the 100-year event and comparison of the lower and upper bound, and that kind of comparison gives you the sense of the uncertainty or the impact of that range of the two climate scenarios, that upper and lower bound that we were using. So that was a very important piece of information to say, okay, so how large is that uncertainty? How large is the potential impact that may come from choosing different climate model or different climate scenario? Then we were able to do some kind of comparison. 250 is the regulatory flood, 100 years is the regulatory flood. In our legislation, that kind of carries a certain particular message, and now it was very interesting to see how these are going to be affected by the climate change impact, and possibly generate some recommendations that may go into change of the regulations, and so on. So these are really the types of comparisons. These comparisons can be shown again in the kind of graphical form. What you see here in the different colors is actually now the difference, the percent difference in risk between the two compared scenarios. So the answers to some of the questions that are posed by setting these analysis scenarios were at the end answered by generating maps like this. In addition to presenting the maps, we are now able to actually go straight into each of these dissemination units and use the information, the GIS information available, and clearly see what are the consequences, what are the impact. For example, in some of the analysis we identify particular cells or particular dissemination areas. You can identify them on the map. This is the Pottersbrook Creek and the culvert that I mentioned, and this is the comparison of the 200-year lower bound and 100-year upper bound scenario. And you can see the impacts of this backup effect extremely seriously affecting the population in this area. And that's now possible. You can actually see exactly where the red spots are, where the areas of high risk are, and you can also find out what is the level of risk, what is contributing to that particular level of risk, so what are the pieces of infrastructure being flooded here, and then prioritize your adaptation options or adaptation policies. Similar thing, this is the downtown area, also another sensitive area. We have a dike here, and this dike provides the protection, but not for the conditions under the climate change. And you can see, actually, this is more yellow than this. If the flows that the climate change scenarios are bringing to occur, the whole area behind this dike may be affected, which is a pretty serious, risk to the city. And so on. This is another example where we have the one of the critical infrastructure, the particular high school, the school, and yellow and blue are showing the kind of difference between the two climate scenarios, which does not look in the extent of inundation significant, but in the depth, the difference is considerable, and therefore the damage, to this particular critical infrastructure type is pretty serious. So you have options now that, from the map that kind of provides the overall allocation of risk. You then, look into the details, identify what are the pieces of infrastructure, and select the adaptation policies. This is a very kind of quick walk through the detailed process that we implemented in the City of London in this particular study. And I'll repeat the messages. I think it is very clear that in this particular case, urban environment in infrastructure in the city of London is vulnerable to climate change. And we looked only one particular impact. We looked only the river flooding that may come from the rivers that are going through the city. We also have all the figures that are indicating the cost. I'm not allowed to use the figures and tell them publicly yet until they go through the city council. I've been criticized because I was doing that in my previous presentations. But I can tell you that the cost of potential flooding that these two scenarios are bringing are very, 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 very high for the city of 370,000 people. I'm strongly suggesting that we will not be able to eliminate the risk. It is very clear that simply the extent of the risk is so high and the capacity of the municipality is exceeded many times. So we will need to find a way to actually adapt to that risk, and that will, I think, utilize the information from the study like this, where you can see and understand what is the level of risk, where it is located, and then derive and find out what will be the best adaptation policy that can match the available resources. I think we, through this study, provided this comprehensive methodology. This methodology now can be applied in any, I think, municipality. I'm not saying this is the way to do it. I'm saying this is one way to do this analysis, but I think the results are kind of justifying and providing useful information to those who may need this and use this information. And again, to repeat, I feel that the changes are occurring. Everyone who talked this morning and before me already pointed out that you in your municipalities are seeing the change, facing the problems, dealing with these problems, and kind of delaying to include the climate change into this analysis, I think will just increase the cost of the future adaptation. With this, thank you very much for your attention. I'm not sure, do I have questions?
Yeah, you have time.
Okay, so we have some time for questions. I'll be very happy to answer. Let me tell you that all this whole study, we have a number of reports, a lot of results and a lot of models available, and the easiest way to go is to my website, click on research, and this is the name of our facility, and then projects. And then you will see under the title the project that's related to the City of London. And then within that area, within that web page, we have all the information, and that's all available. Because that was the research project done with the support of the city. Questions? Go ahead.
Hi there. I'm Renee Hepburn-Rickett with the Insurance Bureau of Canada. And I'm just wondering if you have thought about doing a cost-benefit analysis where you talk about potential adaptation measures and then talk about the potential costs versus you're saying they're very high.
Yeah. I'm
assuming that any sort of adaptation would have some sort of benefit.
That's a great question and a very logical next step. Yeah. And we, since I'm coming from the university and the institute, and I was involved with the research project, we will not be doing that. But one of the very strong recommendations provided to the city is to proceed with a very detailed study, because they will need to reduce the number of options. Oh, sorry, they will have only limited number of options to consider. Budgets and everything else is limiting that set of options, and finding out which one is the best one to proceed or to somehow prioritize. I don't think that the risk is the only objective or the only criteria they should use. We did some preliminary analysis by bringing in some social information that's available for the same dissemination areas from the Stats Canada. So we brought the income, the gender, the various other impacts, and then looked at the same dissemination areas according to risk being only one criteria and adding all other criteria: income, number of female, number of single families, and so on. And I can tell you that immediately the picture changes. So the areas that were red, when we look at only the risk to infrastructure, were not anymore. That coast area carries a very heavy social vulnerability. When you bring the criteria that are reflecting that social vulnerability, that particular area jumps, and that That's something that I think we strongly recommend. We have about 36 recommendations divided in 3 groups that the city is considering, and one of them is to proceed with the detailed economic analysis, benefit cost, but also we are strongly advocating incorporation of the social vulnerability together with the economic and the risk data. Any other questions? Did I overload you with lots of information in a short period of time? Okay. Oh, go ahead.
Going back to the climate change, one argument that's come out is that, and going back to what you showed a 100-year frame, and you showed a 250-year frame. Well, there weren't a lot of people in London, Ontario 250 years ago. And again, what data do we have from 250? And another argument that's come up is, yes, we're going through climate change, but is this just another cycle that the Earth has gone through for, of course, hundreds of thousands of years?
Okay. I need about 2 hours to answer this. But I have the presentation to answer these questions. Okay, so the first statement, 100 and 250 years is wrongly interpreted. I'm talking about 100-year return period. So this is a statistical measure of the probability of flow that occurs once in 100, or every year with the probability of 1/100. Okay, so we're not talking about 250 years back or 100 years back. The issue of the climate change, existence of the climate change or non-existence of climate change was beyond this particular study. I think there is a very strong scientific consensus that clearly documenting that our climate is changing. The key debate or disagreement is in the area who is contributing to that. Are we contributing to this change, or this is something that comes from the natural cycling? And I think this is, the fact is that the climate is changing. We are seeing more frequent extremes. We are seeing increase in temperature. There are observations of the last year was the warmest year on record, historical record. I'm talking about global data. We have a permanent and very strong increase in the concentration of the greenhouse gases. So only the observations, the measurements are very clearly indicating that there is a change. I really don't think that we have time to hold on and discuss who is guilty, and because the cost is piling and it's going to affect all of us.
Great presentation. So you spawned 2 questions. Follow up on the first question. It seemed to me that based on the work that you've done, you've identified what would appear to be some low-hanging fruit, and that is some hydraulic bottlenecks with respect to the sizing of culverts. Have you done any analysis to demonstrate what level of risk reduction you would achieve if those culverts were properly sized for the kinds of storms that you've modeled? And then the corollary to all of this is, to what extent has this work informed the work of the Conservation Authority, which has the overarching responsibility on flood management? Great question.
Okay, so first question, we didn't do that. The project, the project was supported to develop the risk assessment methodology and perform the risk assessment. The adaptation, now the basically selection of the adaptation options and all other, I think, choices that city will have in order to deal with that level of risk is in their hands. The second one is the Upper Thames Conservation Authority was involved very closely with the project. The city was the main funding source, and they actually raised that interest, and this is why they were kind of pushing us to look at the infrastructure, municipal infrastructure. But Upper Thames Conservation Authority really helped, especially with the hazard analysis. And we also, on their request, extended and used some of these results to do some little bit more detailed analysis for the whole Upper Thames watershed, to look at the kind of seasonal impact and analyze, the impact on IDF curves for them, and answer some more detailed questions that are within the responsibility of the Upper Thames Conservation Authority for flood management in the whole basin. They're very much interested in the questions of possibly addressing the change of the regulation and what needs to be done, what would be the consequence and how. So they were part of it. Unfortunately, they didn't have financial resources, for example, to continue with a much more detailed study. And I think in this case, city really provided the leadership and had the resources to actually do this and help also, I think, what the Upper Thames Conservation Authority is responsible for. Any other questions? Thank you very much.